Hello class 9. In today's video we are going to learn about electric current. In the previous video we have learned that when a battery is connected with a bulb and a switch controls it, okay, and when the switch is kept on, the current flows through the wire, okay, makes the connection and the bulb glows and the current return back to the negative terminal, and this is how a battery starts current starts flowing from the battery. Okay, so what is a current then? So actually a current is the flow of charge with respect to time. So we can say a flow of charge in time t. If we define this current, then the definition of current can be the rate of flow of charge across a cross section perpendicular to the direction of flow of current. So let's say that there is a wire. So this is a wire, okay, and the charge flows through the wire, and at this particular cross section of the wire a certain amount of charge passes through in particular time. Okay, so through this cross section, how much amount of charge flows through, how much amount of charge passes through this cross section in unit time, that amount of charge will be known as the current. So it is the rate of flow of charge across a cross section which is perpendicular to the flow of to the direction of flow of current. Okay, so this way the current is flowing and this is the perpendicular to the flow of the current. Okay, so this how much amount of charge will flow is considered as the current. So current is represented by I, which is equal to the amount of charge which flows through in particular time t. So current is equal to charge q by time t. Current flows because of movement of electrons. We all know that the the elements are made up of subatomic particles and electron is one of them, and electrons are negatively charged. Okay, so these electrons are free to move. Okay, and this movement of electrons only produces the current to flow. An electron carries a negative charge and its value is 1.6 into 10 to the power minus 19 coulomb. So if there are n number of electrons which passes through the cross section of a conductor in time t, then the total charge which will pass through can be written as q, which is equal to n into e. Okay, number of electrons n into e, and the current in the conductor, that is I, which is equal to q by t, will be represented now as Ne by t, because q is equal to n into e. So q is replaced by Ne divided by t. So this is the amount of current which will flow in the conductor at the time t. Now since we have said that current flows from the plus terminal, positive terminal, and it does the work in certain appliance and returns back to the negative terminal. But actually it's the electrons which move in the reverse direction. Okay, electrons exit from the negative terminal, it moves from negative terminal and moves towards the positive terminal. Okay, so when the electrons move in this direction, okay, how can current flow through in this direction? Because we understand, okay, conventionally it has been accepted throughout the world that if electrons flow in this direction, then we'll consider that the current will flow in the opposite direction, because the current is supposed to flow from positive to negative, from higher potential to lower potential. Okay, so conventionally the direction of flow of current is taken in a direction opposite to the direction of flow of electrons. So if electrons flow in this direction, then the current will be flowing in the opposite direction. Okay, so if this is the electrons flow, then the opposite direction is the flow of current. Next, over here the same thing, if the electrons move from negative terminal to positive terminal, then the current always flow from the positive terminal to the negative terminal. Okay, whereas electrons flow from negative to positive terminal. Unit of current. As we know now that current is equal to charge by time, so unit of current will be equal to unit of charge by unit of time. So unit of current is ampere. So 1 ampere will be equal to 1 coulomb by 1 second. So from here we come to the definition of 1 ampere. 1 ampere of current is the flow of 1 coulomb charge in 1 second. So this is the definition for 1 ampere. Okay, similarly, if you have a very weak current which is flowing through the circuit, a very weak current, then the unit of 1 ampere may be too high or too big for the current which is flowing. So small units of current is also used. One of them is milliampere, written as small m and capital A for ampere. And also we have microampere, written as mu, capital A, microampere, and milliampere. The relation between milliampere and ampere is that milliampere is the 1000th part of 1 ampere. So we can say 1 milliampere is equal to 10 to the power minus 3 ampere. And similarly, 1 microampere is equal to 10 to the power minus 6 ampere. So these milliampere and microampere are the units, smaller units of ampere, which measures very weak current. Okay, so that much for today's video. Thank you.